So calculate the length of a constant wire of diameter this and this. So if we go by saying, okay, so given all what we have from the formula, we know that resistivity is rho L over area. So that is, and we know that conductivity equals 1 over rho. So this is conductivity. So if you replace it, equals 1 times L divided by conductivity times A. Because if you replace conductivity is just 1 over rho. So if you replace this with 1 over rho, it will give you this, so which is L divided by rho A. So if you apply that in your thing, you are told your rho is 35, your resistance is 35, your length, you don't know your length, that's what you are looking for. Your distance is 1 times 10 raised to power 6. So, and your A is pi r squared, which is pi d times 4d. Your d is 0.6 from mm to meter. So your d is 0.6 mm. So to meter because 0.6 divided by 1000, which is 0.0006. So this will be 0.0006. Everything divided by 4. Everything here squared. That is d squared. So your final answer here, if you punch your calculator, you get it to be L equals 35 times 1 times 10 raised to power 6 times 22 times 0.0006 raised to power 2, everything divided by 7 times 4. So your L, I think we got it to be 990 if I'm not wrong, if I'm not mistaken. So 35 times 10 raised to power 6, so times times 22 times 0.0006 squared divided by 7 times 4. So we have it to be, am I right? So this is 9.9 meter. Please cross check what the answer that we got before. If that one is not correct, then this should be the right answer. 9.9 meter. So we have it to be 9.9 meter, and so that is the correct answer. The length is 9.9 meter. So the second the second is page 2. So you have this. So you have Young modulus and then this. So just like we did the definition, the Young modulus. So if we are to define Young modulus, so you say Young modulus is the measure of elasticity, and this elasticity and elasticity or what's now stiffness here, or stiffness of a material. So it's Young modulus is used to measure how elastic or stiff a material is. So you can use Young modulus. So it's now a question of the next question. So just like we said, Young modulus, the formula for Young modulus, which is E equals to tensile strain, tensile stress over tensile strain. And tensile stress is force divided by area divided by change in length divided by length, change in length divided by length. And this is equals the, if you were to rearrange it, so your this would be force times length divided by area times change in length. So that is the rearrangement, that is FL over A change in length. So that's the rearrangement. So the question now is calculate stress of the wire. That is the question one, stress of the wire. So and here it says stress of the wire, stress equals tensile stress, which is force over area. And because force, we are given force value to be 40 Newton, and area, which is pi r squared pi d squared over 4, and our date from the data given. Okay, let me quickly write data given out. Data given. This should have been what the first thing you do. Your force equals to 40 Newton. Your extension or your change in length equals 0.24 mm. Your original length equals 3 meter. And the diameter equals 2.0 mm. So you need to convert the extension and the diameter. So, and this is 22 divided by 7 times the diameter is 2.0, which is 2 divided by 1000, which is 0.0002, all squared. This is pi d squared over 4. Remember, your force and area is force divided by pi d squared over 4 from area. So this is what you have, and from there I think our answer was, what is our answer again? So what is the answer that we had before? So the answer was 40. 40 divided by 22, that is 22 divided by 7, multiplied by 0.002 squared divided by 4. Okay, should be. So we have our answer to be 1 0.27272 Newton per meter squared. That is the unit. So if you want to convert it to standard form, you can 1.27 times 10 raised to power 7, because from here 1 2 3 4 5 6 7 times 10 raised to power 7 Newton per meter squared. So you can leave it in any of this form. You can leave it in any of the form. So we are told to calculate stress, strain as well. Strain, which is change in length, extension over length, and your extension is 0.24 mm, so you convert it to meter. That is 0.24 divided by 1000. That is 0.0024 divided by your length is 3 meter. So it's 3 meter. So you can do that. That is 0.24 divided by 1000. Oh, sorry, this should be 3 zeros. This should be 3 zeros. 0.0024 divided by 1000. 0.0024. So we have it to be 0.0024. Everything divided by 3. So we have 0.00024 divided by 3, which is equal 0.00 0.00008. So strain doesn't have units because meter cancel meter, doesn't have units. So in terms of standard form, it will be 0.8 times 10 raised to power 1 2 3 4 5 times 10 raised to power minus 5. So that is what you have there. 0.8 times 10 raised to power minus 5. That's what you're going to have. So if you, the next question is now to calculate Young modulus, which is E. Young modulus E. So your E is stress over strain. Stress over strain. We have the formula already from the beginning. So which is 1.27 times 10 raised to power 7 divided by 0.00008. So we have this to be 1.27 times 10 raised to power 7 divided by 0.00008. How many zeros? 4 zeros before it. So this will give you the total of 1.5875 times 10 raised to power 11. So your Young modulus is also Newton per meter square. It's the same thing as tensile stress formula. So that is what you have for this particular question. For this question, so move on to the next question. Can move on to the next question. So the current passing through a metallic conductor is is directly proportional to the voltage applied and the voltage applied across it, provided that
don't buy another charger until you see this.
provided that temperature and pressure remain the same, remain constant. That is Ohm's law. So Ohm's law states that the current passing through a metallic conductor is directly proportional to the voltage applied across it, while then temperature and pressure remain the same. So, which means that the current passing through a metallic conductor, the current I, so your V equals IR. So that's it. That's what it means. Your V equals IR. So in this circuit that we have here, so in this circuit below, in the circuit below, the ammeter reads a current of 3 meter. So the ammeter is 3 meter when R is 5 ohms, and 6 amps when R is 2 ohms. Determine the value of X. Neglect the internal resistance of this cell. So what does this actually imply? So it implies two resistors put in parallel to each other. So how do you solve for X, the other resistance? So how do you solve for X, the other resistance? When you have here to be 5 ohms, that is what will be the value of X here. Giving 3 amps is passing through it. So it is noted, according to parallel law, when you have 1 over R total equals to 1 over R1 plus 1 over R2, blah 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 blah. So, and you should note that your V total will always be your I total times your R total, just like so. For parallel, it will be 1 over this, 1 over that. So if you have what's it called, for current, when your current is 3 amps, your resistance, okay, let's look at this. This is 1 over 5 plus 1 over, let's say, X. So the solution here will be 5x. This will be x plus 5 here, right? So we have it to be x plus 5 to be divided by 5x. That is equation 1. And we are told that this is equals to 3. Okay, don't let us go there first. This is equation 1. So we are told it's equals to 3, right? And the second one we are given another I total. So R total 2, that is 1 over. Okay, so in order for you to find R total, so if you, this is 1 over R total. So R total now will now be inverse if you take it up. So that means this will flip. So this will flip, while this will flip down. So R total is now 5x divided by x plus 5. That is R total. So now, if you now have it to be 6 R1 over R total 2, R total 2 is, when they said when it is 6, is it 6 amps? What do we have it there? When it is 6 amps, R is 2 ohms. So we have 1 over 2 plus 1 over x, same x. So this will be x is 2x, LCM is 2x, 2 times xx, 2x. So this will be x plus 2. So, and our R total now, R total 2 will be 2x over x plus 2. The same, we will flip this because this is going up, so we'll just flip it to the other side. So that is 2x divided by x plus 2. So now you are told that your V total equals I total times R total. V total equals I total times R total, right? So, and we know that the same voltage. So according to parallel law, parallel circuits, same voltage flow. So same voltage flows. So that means V total 1 equals to V total 2. No matter what, so they are the same. So that means I total 1 plus times R total 1 is the same thing as I total 2 plus R total 2. Do you get? So if you now bring this equation now to it, so that means for R total, I total 1, they said 3 amps. From the question, 3 amps, you were given 3 amps. R total 1, so 5x divided by x plus 5. I total 2, 6 amps, multiplied by 2x divided by x plus 2. So if you do this mathematics, this will give you 15x divided by x plus 5 equals, let me remove this equals first so that I will not be confused that which one will be this equals to now. That's giving me very, so this implies this 5x equals x, this is x plus 5, which is the same thing as, wait, so this should be 15x, not x, 15x plus equal over x plus 5, and then this is 6 times 2, 12x over x plus 2. Over x plus 2. So in order for you to find the value of x, you can say that So you can say that your x, if you try to cross multiply, so for your x, you have it to be 12 15x multiplied by x plus 2, and this will be equals 12x into x plus 5. So this will be 15x squared plus 30x equals 12x squared plus 5 times 12, that is 60x. So you can rearrange. If you rearrange it to be 12 15x squared minus 12x squared equals plus 30x minus 60x equals 0. So this can be 3x squared minus 30x equals to 0. So you can actually take 30 to this other end. So you can take 30 to the other end, or you can factor out what is common. Either way that you want to do it, you can take 30 to the other end, saying 3x squared equals to 30x. So what is common in both? X is here, so you can divide through by, and 3 can divide 30, so you can say divide through by 3x. So therefore your 3x squared divided by 3x equals to 30x divided by 3x. As we cancel x, 1x cancel 1x, 3 cancel 3. So 30 divided by 3. So therefore your x equals 30 divided by 3, 10. So that means your s is 10. So that is the value of your x. So that is the value of your x in this question. Can you see now how it looks like? So it's just step by step that you just need to follow and all of that. Alright, so next question will be which one? So we are to have a label diagram of a tall vessel. So let's consider this as the vessel. A vessel let's consider this as the vessel. So we have so we have a bearing dropped inside this viscosity liquid. Can be oil, it can be anything. So when you call, I think if they've taught you viscosity, so viscosity has liquid has high density, so it doesn't allow objects to flow easily. So when object drops, right? So the question is, show all the forces acting on the ball. So there is downward force, the force that is pushing it downward. So this force is named as, there's a force pushing it downward, which is the weight. The weight of the bearing. So the weight of the bearing is pushing it downward. Weight downward. Push downward. So there is another oppositional force called upthrust. So we have upthrust pushing it upward. Push upward. Upthrust. So upthrust actually pushes upward. We have another one that is also acting. So we call it drag. So that one is from the fluid itself. So it will be dragging it. So the fluid is preventing it to go down. So drag force pushes upward too, because it doesn't want it to go down. So those are the three forces acting on the object at the same time. So that is the first question. When will it attain its terminal velocity? So it will attain its terminal velocity so the second one, terminal velocity, is when the upward and downward forces balanced out, that is, becomes 0. So what it means is when your weight W equals upthrust U plus your drag force. So when your weight equals weight is W, U is upthrust plus your drag force, which is your dF. So that is when terminal velocity occurs. So what happens at terminal velocity? That is, the weight, all of this, they balanced out. So the object or the ball, okay, no, so far we are using the ball bearing. The bearing continues to fall at constant velocity. So no change, just continues to fall at constant velocity. So yeah, so that is that about this particular question. Hooke's law states that provided the elastic limit and the elastic limit is not exceeded, extension or compression of an elastic material is directly proportional to the applied force. So that is Hooke's law. Hooke's law states that provided that the elastic limit is not exceeded the extension or compression of an elastic material is directly proportional to the applied force. So that is force equals Ke. So your K times E, your K force is applied force, F is force, K is elastic constant, or called spring constant. E is extension. So that is it. So state two factors that affect diffusion. So two factors that affect diffusion is temperature. You have B1. You have temperature affects diffusion. So that is increase in temperature increases the kinetic energy of a particle. So the second one is mass, molar mass. We have mass or molar mass. So that is lighter particles diffuses faster or travels faster. Than heavy particles. So we have another one to be surface area. So they said 2, but I'm just giving you 3. Surface area to volume ratio. Surface area to ratio volume. So this implies that if you have surface area, larger surface area to volume ratio diffuses faster than lower one. Diffuses faster. Yeah, so that is another one. So the other one is state 3 advantages of mercury over what's it called? The very common one. Is it number 3, Abby? Advantages of mercury. So mercury doesn't wet glass. Mercury does not wet glass. So what it means is it doesn't, if you put mercury on a plate, it doesn't wet. You just stay like a solid, not really solid, like it will just stay there, so it doesn't wet glass. You will not see a drop of it anywhere. Everything will just pack together as one. But water does. Alcohol can wet a glass. Water wets glass. Do you get it now? So the other two is mercury is shining. It's shining. So it's shining. So which is visible against white background. So mercury is shining while alcohol is colorless. So mercury, just like the way the first one, mercury expands uniformly. This is E, expands uniformly. So it doesn't act haphazardly, so it's everything just go, and it has mercury as high boiling point, so it can take higher reading. So before it evaporates, it takes a long time before it evaporates. So I think we were told to mention 3, right? Cells. Let's see, cells. Let's say battery, 2 battery. This plus minus. Having EMF of 2, 2 identical. So they are both identical. We have 2. Let's say plus, this one is plus 2, this is minus. Let's say they are both connected in series. So far is in series. So positive to negative. So an internal resistance, so they are 2 volts. An internal resistance is 0.5 ohms and 0.5 ohms. That is internally. So connected and with a coil of resistance. So there's a coil in between them, which is 3 ohms. You use coil to connect them, which is 3 ohms. So the effective internal, so the effective EMF, so EMF that is effective, EMF effective, so equals the total EMF, that is 2 volts plus 2 volts, which is 4 volts. So that is the total EMF, because they are all in series, so the voltage will be added up, because series voltage in series always adding up. So excuse me, sorry. So we are told internal resistance, the effective internal resistance of the cell. So EMF, sorry, I said EMF, effective internal resistance. So IR, internal. So okay, let's just say resistance. Resistance effective equals 0.5 ohms plus 0.5 ohms, which is what? 1 ohms. So which is 1 ohms. So that is the internal resistance. So for the current in the circuit, right? So for the current in the circuit, so current, the effective, okay, so the current in the circuit. So because we have this, we have this, we have this, so current is what's the current again? Current is IR equals voltage, Rabi. That from Ohm's law, voltage equals IR. So your I is current equals to voltage over R. So and the voltage you have is effective EMF, which is your EMF effective. So the R you have resistance effective plus resistance external. We have external resistance of this coil, which is 3 ohms. So because of that, your I will be equals to 4 divided by 1 plus 3, which is 4 divided by 4, which is 1 amps. So your I also is 1 amps. So if your I is 1 amps, the third question is the potential difference. So potential difference is the current that you are taking out from what's it called, the internal resistance that you have. So we have two, so far is in series, same current will flow, same current will flow through. So for potential difference is so you can just say V equals to IR. So your VI is 1 times your R3 resistor. Potential difference is still voltage, so which is 3 volts. So that's the answer. Looking at so to express dimension of the following, I should even leave this one for you to do. So if you are to express the dimension, oh god, I believe you've been taught dimension. So what is force? Force is mass times acceleration. And mass is measured in m, acceleration is measured in speed. Acceleration is still the same thing as and velocity times velocity divided by times squared, that is velocity, which is like distance over time. So distance over time, velocity is displacement over time, and displacement is length. So acceleration, this one will give you v velocity divided by time. and velocity, because dimension, you need to take it to the lowest unit, to the scalar unit, lowest, the basic unit, which is mass, length, time, and which other one again. So you need to take it to the, so you have time already. This velocity is displacement over time. So you have two time, so this and time and time. So you can say acceleration is displacement over time squared. So displacement is the same thing as length, so this is length divided by time squared. So your force is ml per t squared. So you can write it to be ml like this per t squared. So this is your unit. So for power, what is power? Power is what? When you have power, Lord Jesus Christ, help me. So how do you do dimension of power? It's still the same process. You firstly kind of take it to the lowest. What are the power is work done based on definition. Work done divided by time. And this your work done is the same thing as force times distance. So you've already calculated for force already, so you just input it. That is ml, let's say t minus 2 is still the same thing as part. This thing is still the same thing as this, multiplied by distance L divided by time again. So what do you going to have? You have it ml squared per t3, because this is like division. It's still the same thing, like ml divided by t squared times L will be up. So far, so that you'll not be confused. This is the answer, I'm just rewriting it again. ml divided by t squared is what you have before, times L, everything divided by t. So this is what you have. So if you do your maths, so this will become ml squared divided by t squared divided by t over 1. So if you take this to be multiplication, so that is ml squared divided by t squared times 1 over t. So which is still the same thing as this. So that is for power. For pressure is what? That is force, Newton per meter squared, force over area. So pressure is force over area. So, and your area is what? That is meter squared. That is length times breadth. So your area is length times breadth, which is meter squared, right? So your force is ml t minus 2. Your area is L squared. That is area. Length times length. Area of a square, area of a triangle. So in this case, you use the lowest unit. So not pi r squared, the area of a circle. That gave it like basic. What is the basic unit of area that you could have? The smallest, which is L squared. So this is what you have as the stuff. So 1L can cancel 1L. So you have this to be m divided by L t squared, which is m minus 1 T minus 2. So that is pressure. So the next one is density. So density is what? Mass over volume. That is the formula. So mass over volume, mass is M is mass, volume is meters cube, which can be L cube. So L cube, that is length cube, will be the volume of a thing. So so in this case, it's still the same thing as ml minus 3 of a thermometer. Let's say it starts from 0. That is the sorry, not 0. The lower here is 30 and the upper here is 180 millimeter. That is 180. So they now said what will be, so this is length parameter. They said what will be the degree at 45. So you are comparing it with when it is 0. When it is 0 to 100, what will be the length? All right, so the interpolation. So in this case, you use what we call interpolation. So what interpolation is saying is, at the degree you are looking for, this one is your x 45 minus your x 30, which is the lowest point, which is referring to this, divided by your x 180 minus your x 30. So what you are doing is you are comparing from top to bottom, then from this place to bottom. What would it be? So times 100, because your unit is from 0 to 100. So in this case, so that is just interpolation, middle to bottom, then top to bottom, not middle, any data that you are giving that you are looking for. So this gives you 0, this gives you 100, this is length, this is in millimeter, this is in degree, this is in degree, this is in millimeter, as the question gives you. So don't forget this is in millimeter. So you have to find equivalent of this in degree. That is what you don't know. So 30 millimeter will be 0 degree, 180 will be in form of 100 degrees. So that is why you use that equivalent to perform it, and that's why we multiply by 100. So in this case, you have it to be 45 minus 30 divided by 180 minus 30. So 45 minus 30, this should be 15. 180 minus 30, this should be 150 times 100. So if you, that is 1500 times, so 15 divided by 15, so that means will be 10 degrees Celsius. So that is how to interpolate